next revision class about the enthalpy change of neutralization. It is the enthalpy change when an acid is neutralized by base to give 1 mole of water. Okay, so when an acid is neutralized by base to give 1 mole of water. So you can find here that I didn't mention the standard at in the neutralization at the standard temperature pressure, like I previously mentioned. Why I didn't mention that? Because in case of neutralization reaction, there is there is no influence of any pressure and temperature change. If you that in this neutralization reaction, what is happening? Acid is neutralizing the base, or base is neutralizing the acid only. Even you go to the Mars or you can go to the moon, this thing will be same. This neutralization process will be same. So this is in case of neutralization, enthalpy change of neutralization, you don't need to mention the standard temperature pressure or standard condition. But in case of any other definition, if you don't mention that, their marks will be deducted. Okay. So now here we will discuss one sum related to this topic, and I will, after the discussion of this sum, I will give one worksheet related to this sum. And Tuesday is the your assignment date for the previous sum and this sum. Today what I will give. Okay. So the sum is 50 centimeter cube of 2.0 mole per dm cube sodium hydroxide solution were added to 50 centimeter cube of 2.0 mole per dm cube the hydrochloric acid. Okay, so this sodium, what you need to remember, this one and this one, this is your first two important thing. 50 centimeter cube, that means the volume, and 2.0 mole per dm cube, it is the concentration of the sodium hydroxide. For this hydrochloric acid, also 50 centimeter cube is the concentration, and 2.0 mole per dm cube is the 2.0 mole per dm is the concentration for the hydrochloric acid, and 50 centimeter cube is the volume. So first what we have, then initial temperature of HCl is 17.5, and initial temperature of NaOH is the 17.9. Then the final temperature is 31.0. Calculate the enthalpy change of the neutralization. I don't know what is this one. Okay. So, average initial temperature. So, what is the average initial temperature? The temperature of HCl is 17.5 and temperature of NaOH is 17.9. So, we take the average, it's 17.7. And mass, as both HCl and NaOH are reacting in this reaction, means both are in the reaction. So, we are added up both the mass here 50, here also 50, both we added up is 100. So what is the energy generation of the Q? Sorry, yesterday class I told that Q and delta H is the same thing, but sorry, Q and delta H is not same thing. Q is the total energy and delta H is the enthalpy change. Okay, so total energy is releasing in this equation, in this reaction, is we can found it by m, c and delta t. M is 50 plus 50 is 100, and this is the C, the specific heat of water, as both the solution, the HCl and NaOH, are so diluted. So we will take the specific heat of water only. Okay. So M, C and T is the delta T, the temperature change. So 100 multiplied by 4.18, that is the specific heat of water, and 31 minus 17.7. So the answer is 55.60. Now you see the equation. The equation tell us that 1 mole of HCl is reacting with 1 mole of NaOH. Okay, both are same mole. NHCl. So N mole of HCl is neutralizing the N mole of NaOH. Both are similar moles. So number of moles, if we calculate the number of moles of HCl, it should be same for the NaOH also. So number of moles in the reaction C into V. How can I find the number of moles? Concentration into volume. Okay. So now, sorry, here I first add the, no, this is the concentration and this is the volume. Okay, 50 centimeter, and concentration is here you can see the concentration is in the dm per cube and the volume is in the cm per cube. So that's why we divide the volume by 1000. Okay, so answer is 0.1 mole. So the 0.1 mole, so the 0.1 mole gives out this energy. Why? Because as what is the definition said? The definition said is the enthalpy change when an acid is neutralized by the base. Okay? The enthalpy change when an acid is neutralized by the base. Okay? And to give 1 mole of water. So here this 1 mole of HCl is neutralized the 1 mole of NaOH. Okay. So that 0. So 0.1 mole when neutralized the 0.1 mole of NaOH generate that much heat, generate this 5560 joule heat. Okay. So now we can find how much heat generated by the 1 mole gives out. 5560 divided by 0.1, it is 56000 joule. That means 56 kilojoule. So the enthalpy change of neutralization is minus 56 kilojoule, as it is exothermic. Why it is exothermic? Because final temperature is increased from the initial temperature. Initial temperature, average initial temperature is 17.7. Okay, and final temperature is 31.0. So which one is bigger? The final temperature. So that means energy is given out. So when the energy is given out, it is called as a exothermic, and when a reaction is exothermic, we will give the delta H, the enthalpy change should be expressed as negative. Okay, thank you. I think you understand this sum. So today I will give another worksheet for related to this sum, and yesterday I gave another worksheet. Yesterday I gave one worksheet. So for both worksheet, the assignment date is Tuesday. Try to solve it in the Tuesday and give it to me. Thank you.